Good morning, and I'm just so happy. This is one of the happiest days that I can remember. It's such a wonderful occasion, and we're of course going to be dedicating this new building that represents so much of our hope and planning for the future. I'd like to start by acknowledging many special guests. We have here today Mayor Tom Bates from the city of Berkeley, California Energy Commission Commissioner David Hochschild. We have representatives from Senator Boxer's and Congresswoman Lee's staffs. State Senator Lonnie Hancock's District Director Terry Waller is here. And of course many other representatives who you will be speaking very, very shortly. I do want to start by saying at the outset that what this building represents is really our hopes for the future and also our plans for the future, in the sense that we'll be performing research inside here that will enable new ways of harnessing solar energy. So while we are going to be dedicating some very beautiful modern architecture, steel and glass and so on, it's not really the building that we're here to celebrate. It's our hopes about the power of the ideas that will come from it. And as we face issues about what the future will look like in terms of climate change and environment, in terms of our energy future, we know that there are many things that we can do already as a society with the technologies that we have. But there's also the possibility that we could really make new discoveries that would enable us to live in a sustainable way and yet still have access to clean and renewable energy. And to do that really does require that we think hard about the fundamentals of energy, and that we think hard about the deepest science that goes with it. And so it's extremely fitting today that this building is going to be named after the single greatest proponent in the world today for the use of our best scientific minds to lay the foundation for the future of energy. I'm referring, of course, to Steve Chu, who this laboratory is deeply, deeply grateful to for his leadership here at this lab, where he came and set a tone and a way of working that has transformed us, and also for his great leadership on the national and international scale after he left here and went to the Department of Energy and became again the greatest advocate in the world for saying that if we really think about the fundamentals, then we have a chance to deeply produce the kind of change that we need with new technologies and new science. So it's a very fitting and wonderful occasion. This building, of course, embodies the potential for all of this. It's wonderful, beautiful new infrastructure. And such things don't come about just by accident. We've had, in this case, what I believe is truly a model of public-private partnership, and there are so many dimensions to it. We have had terrific support from the state of California. The Public Utility Commission and the California Energy Commission have really contributed significantly to helping this building come together. We've had true private assistance and aid through the Simons family, and we'll be hearing from them shortly. We have here today visiting with us Bob Kahn, the president of the Kavli Foundation. The Kavli Energy NanoSciences Institute will be located inside here. It will investigate the fundamentals of how energy is converted on the nanoscale. We're deeply grateful to you for your contributions. So, and of course, the Department of Energy. This building will house the northern section of the National Energy Innovation Hub that's dedicated to solar to fuel. That's a program that's led by our friends and colleagues at Caltech and has substantial participation from our friends at Stanford as well. And I just want to mention that that program really is the heart and soul of what the research is that will be going on inside this building. Over 30 years ago, Melvin Calvin at this laboratory envisioned the possibility of photosynthesis being harnessed on a large scale for the benefit of humanity. As he understood the carbon cycle deeper and deeper, he came to be a strong advocate that we might one day build artificial photosynthetic systems that operate at much higher efficiency than natural plants, like the ones we see right next to us and in our environment. But that was a big stretch in those days and not yet realizable. The Joint Center for Artificial Photosynthesis has been running for a few years now, and I'm very proud to say that in their first 5 years, they've reached a very key milestone. They now can make a system which absorbs sunlight like a conventional solar energy panel, but it's immersed in pH 13 water. And as it's irradiated, the materials that are in there are ones which for 30 years everyone believed would be photodegraded immediately. In fact, they always were before, would be photodegraded immediately under that illuminated and corrosive environment and simply be destroyed. But controlling materials on the nanometer scale with atomic precision, there's now a prototype running here inside this building today, which is made out of those materials that have been unstable for so long, now operating completely stable for many months in a row at 10% power efficiency, taking the power of sun and splitting water into hydrogen and oxygen. That's an example of the world of science being harnessed to solve what had been a multi-decadal challenge. And inside this building in the future, the scientists here will be turning their attention to going beyond the splitting of water, which produces hydrogen, to looking at the possibility of taking CO2, carbon dioxide, the material that our engines exhaust and that is changing the temperature of the Earth, converting that CO2 and water into a usable fuel. It's a grand challenge, and it will engage the best minds at Caltech, Berkeley, Stanford, and other institutions that will come here and collaborate. So I think, again, it's a truly fitting location to be named after Steve Chu, who has played such a vital role in helping set our nation's sights on such an important and worthy goal, and who has done so many other great things. Now, we have a series of folks who are going to say a few words about this occasion. I'm particularly delighted today that we can start locally. The Berkeley Lab enjoys today the warmest and deepest connection with the community around us, and that's because our work truly embodies the values of the community that we live in. And so I'm very excited today that we're having here present representing our local community, Berkeley Mayor Tom Bates.
Thank you very much, Paul, for the introduction. It is really a pleasure for me to be here and to have an opportunity to see Steve and Chu again. Steve, of course, was the director here when I first got elected to be mayor of Berkeley, which some time ago, like 13 years ago. But it's been a wonderful relationship, and I really got to know Steve when our lunches that we held quarterly. And Steve actually taught me a lot about what I hope to be the future of our country, which is to get off fossil fuel and to move to energy that's renewable and can be used for future generations to save the planet. So it's a great pleasure for me to be here. I really love having Steve, and I told him a little bad about he's got a Stanford on there, but he claimed he was dressed in blue and gold, so he was okay. But it's great to have him back, and Steve, thank you so much for the work you did here at the lab, the science that you brought here, and also the work you did at the nation and as a Director of Energy, Secretary of Energy. You know, we really are all indebted for your leadership and your vision, so thank you very much. And this building is only fitting that it be called Steve Chu Building. Thank you.
As I mentioned earlier, the state of California really is leading the world in thinking about how we can create a future energy system and to have really a strong environmental stance while also having great economic development. And the state has really helped the Berkeley Lab in many dimensions and has helped the solar energy research activities here in many dimensions, for which we are deeply grateful. And so the Public Utility Commission actually has made a significant contribution towards the funding of this building, and many of the programs inside here have also received some support from the Energy Commission itself. So we're very honored and very fortunate to have here a member, Commissioner David Hochschild of the California Energy Commission.
Well, good morning and welcome, friends. You know, we're giving a lot of love to the building, but let's not forget there's also a Chu Road. I want to give a little love to Chu Road, which is a wonderful road. And when people say Steve Chu is curvy, we're really referring to the road, not the building, just to be clear. So I think it's useful, actually, to every now and then go ahead 20, 30 years and imagine looking back on this moment today and asking the question, what are we glad we did? And what do we wish we would have done, right? And I think this is going to be one of the decisions we're going to be very glad that we as a state have done. Investment in innovation is driving the clean energy economy of the future. And California, just if you look around at what has happened, the change where we're doing basically the extreme home makeover for energy, and it's working. You go back to 2008, we had 12% renewables in the state of California. December, we hit 25%. We're fully contracted to get to 33% by 2020. And the governor has laid out a goal to get to 50% by 2030, which flips the script and makes fossil fuels the alternative energy and renewables mainstream. You look around the state today, we have the largest wind project in the world, the largest solar tower project in the world, the largest solar trough project in the world. We just dedicated 2 months ago the largest thin film PV project in the world. We're going to be dedicating the largest crystalline PV project in the world. The largest manufacturing operation of any sort in the state of California today is an electric car factory, okay? We are getting it done. And the skeptics and the critics, you know, the people who say it can't be done need to get out of the way of the people who are doing it, because we're here and we're making it happen. I wanted to again just thank Steve Chu for really being the pioneer, you know, leading this parade. It's great to dedicate this building in your honor today. Thank you.
So we're at the Berkeley Lab right now, but there's really no border between the Berkeley Lab in some sense and the University of California, Berkeley, the greatest public university in the world. We're so fortunate to have a deep, deep tie with the Berkeley campus, and the students and faculty are able to engage with their creativity and to be part of what the laboratory here can do on a larger scale. And that partnership is very, we experience it daily, and it's at the heart of every aspect of this laboratory. And so we are just deeply, deeply grateful to the UC Berkeley community for their engagement here at the lab. And we're very fortunate today that the Provost, Claude Steele, can be here with us to say a few words.
Thank you, Paul. It's a real pleasure to be here and to represent UC Berkeley and its connection to Steve Chu, his long career, he was an undergraduate at Berkeley, if I have that correct. Graduate. So we're very proud to affirm the career and to affirm this tremendous project. He was one of Berkeley's most accomplished graduates, received his PhD from Berkeley's physics department in 1976, and was advised by the legendary Gene Commons, who is also here today, if I've been told. After receiving his PhD, he continued to serve as a postdoc for Gene and was offered an assistant professorship in 1978, but he was under such demand at that time that he took a position apparently at Bell Laboratories, and after being there for a while came to Stanford and was served on Stanford's faculty for many years. Our paths actually crossed there a little bit on some campus committees, so I remember that well. But UC Berkeley was especially delighted, of course, when he returned to Berkeley to become the director of the Lawrence Berkeley National Laboratory in 2004. We were also immensely proud when Steve was appointed to serve in 2009 as the 12th United States Secretary of Energy. Steve's service to the university has been exceptional. His contributions to basic science have been immeasurable. His outspokenness about the threat of climate change has been of dire importance in this society. Steve, UC Berkeley is honored to have been part of your incredible and continuing path, and we are delighted to participate in this collaboration honoring your work. A collaboration like this one represents the best for basic science research, which these days is an area we are all fighting for. While the research undertaken here is in response to necessity, it will sometimes result in applications and sometimes not, but regardless, basic research lays the foundation for the advancement of knowledge. So I thank and praise the supporters, public and private, of this endeavor, the state, the Department of Energy, the Simons and Sea Change Foundations. Thank you for your generosity and for your understanding that discovery and innovation are intertwined with basic research. Lastly, I also want to acknowledge a few campus colleagues who understood the importance of this project and how to accomplish it. Former Executive Dean of the College of Letters and Science, Mark Richards, and Chancellor Emeritus Bob Bergeneau. Thanks to many players who made Chu Hall possible, and best of luck to its researchers in their frontier work. Thank you.
Well, as I mentioned earlier, the world faces many challenges, and particularly many in the area of what will happen with our environment. And for us to really set the stage for the kind of change that's needed, we require partnerships across all parts of society. And we're so fortunate that the Simons family is playing the role that they are in pushing our society to have more devotion to very fundamental science, and at the same time more devotion to issues that relate to the environment and to how we can steward it in the future. And so those two twin interests, of course, have led them to make a very significant and important contribution to this project. And we are deeply grateful to you for that. And we are deeply grateful also for your patience, because the project took a little while, and you have been steadfast in your support. You also have played a vital role in helping us to garner the support from the Kavli Foundation for the Energy NanoSciences Institute, and that will be an ongoing and vital piece of the programs that go on here. So we're just delighted here that today we have Jim and Marilyn Simons here, as well as Nat and Laura Baxter Simons and Mark Heising and Liz Simons all here today from the family visiting and to participate in these very special events. Your contributions have been beyond just essential. I think I can say with absolute confidence that we would not be standing here had it not been for their generosity and also thoughtfulness. And so Nat Simons and Liz Simons are going to say a few words.
Hi. So when my brother Nat, my sister-in-law Laura, and my husband Mark met Steve Chu about 10 years ago now, we were really jazzed after we had that first meeting, and one of us thought that a funny headline could be, Nobel Prize winning physicist wants to save world, needs cash. So soon later, my dad had the pleasure of meeting Steve Chu, and then after reaching détente with a few trees, some neighbors, and a tritium plume, the rest is history. We now have this beautiful building, and the promise of solar power is brighter than ever. So our coming together as a family to support Helios was a really wonderful thing, and really marked the first time that we'd ever come together as a family over something philanthropically. It was a great pleasure. And it's interesting because the idea of supporting a building rather than a program took a little getting used to, but the prospect of so much great science happening under one roof and the possibilities of synergy made it enormously appealing to us in the end. I should mention that besides Steve Chu, we were also tremendously inspired by Paul Alivisatos and Jake Kiesling, who really wowed us with their research presentations. And also, we were very inspired by Bob Bergeneau, Mark Richards, and John McKee, who were really amazing at navigating what turned out to be a rather tortuous path to groundbreaking, and of course we're so devoted to Helios. So thanks to everybody, and what's really exciting to me is now we can start using the word groundbreaking in an entirely new, better context.
Okay, I'm not going to add too much to that. But I couldn't help thinking as the FedEx truck rumbled by during Paul's opening comments, how if we had done a better job with EV deployment, we wouldn't have to deal with all these interruptions. So it just goes to show how far we still have to come. And the fact that this took such a long time and did take a circuitous path and not the path that any of us had envisioned may be indicative of the difficulties associated with the task at hand, but the need to be persistent. And the persistence that everybody showed in making this project happen, and there are too many people to name, is reflective of the goals that we're setting here and the importance of those goals. I do want to point out, though, that this is a global problem, and one thing that that has changed from the time that this project began was atmospheric concentration of CO2 has moved from 380 to over 400, and that's not a number that that we have much we can do to reverse it at this point. So the fact is that time is not our friend. Hopefully we can speed progress, and hopefully with the ribbon-cutting ceremony of this building and others like it all over the world, we can find ways to much more rapidly deploy, discover, and really implement the kinds of solutions that we need to move forcefully to a clean energy future. So thanks everybody here for playing their part.
Well, that's exactly right. We have our work cut out for us. A shout out quickly. I see Arun Majumdar here. Arun also was here during the period when this was all being conceived, and then went on, of course, to ARPA-E, where he was the founding director of what's been a great program. But Arun today has got a little group that's thinking hard about could we pull CO2 out and go the other way. So let's keep thinking hard about those ideas. As I mentioned to you in my opening remarks, the group here in its early work, which was in rental space in Potter Street, not too far from here, and working with the colleagues at Caltech and Stanford, accomplished something which actually I have to say, it was an audacious goal when the Joint Center for Artificial Photosynthesis was first established, and at that time, every material that had been tried really fell apart under the conditions that would be required, and now they have it working with some ingenious control with new catalysts and better light absorbers, and the whole thing's going extremely well. And another thing that's wonderful about it is the extent of the really deep partnership that exists between the various California institutions that are working together on this. And that's a testament really to the leadership of the organization. We have here today Frances Houle, who's the leader here at Berkeley of the Artificial Photosynthesis project. We co-opted her from IBM and some other places. And Harry Atwater, who's a professor of applied physics at Caltech and the overall head of the Joint Center for Artificial Photosynthesis for the Department of Energy. Frances and Harry, with their leadership, have set the tone for cooperation and also for really fostering a truly deep and also fast-moving program. So it's a pleasure to invite them up to say a few words.
Thanks, Paul. And so I want to welcome everybody here to our new home here at Lawrence Berkeley Lab of the Joint Center for Artificial Photosynthesis in Chu Hall. And I hope you'll take the tour because downstairs you'll see an operating solar fuels generator. And this solar fuels, generating fuels from sunlight, was and JCAP, the Joint Center for Artificial Photosynthesis, was a response to the audacious challenge by today's honoree, Secretary Chu, to really make rapid progress. And so JCAP began essentially, as I like to think of it, as a basic and translational science startup company. And like all startup companies, it started with a bold idea, a team of people anxious to do it, some support, but not any space. And both at Caltech and at Berkeley, the teams began work, launched the research program immediately, and in the due course of the 5 years of the first phase of JCAP, built 2 beautiful laboratories that, in addition to the steel and glass, give us tremendous capability. And this is the capability that complements the ideas and the people, the tools and the capability of the lab you'll see here downstairs that really gives us the ability to make rapid progress. So JCAP is the Joint Center for Artificial Photosynthesis is indeed a partnership between Caltech, the lead institution, Lawrence Berkeley Labs, and I'm very fortunate to have Dr. Frances Houle as my partner in leadership of JCAP. And we also includes a partnership with the Stanford Linear Accelerator Lab and Stanford University and the University of California at Irvine and San Diego. So it's a partnership that spans the great state of California. So we're grateful to the state here for the support. And the support in the forms of the 2 laboratories that gives these capabilities has been very inspirational to us and is a fantastic resource in both locations for our renewed mission to generate fuels, liquid fuels from sunlight, carbon dioxide, and water. So we have some water here today, sunlight, and as some of the other speakers have mentioned, all too much CO2. And so the audacious challenge of JCAP now is to do something to turn the CO2, which is essentially a waste product and our biggest challenge in terms of aggravating climate change, turn it into a resource, a renewable resource. And so I'm going to ask Francis Houle to tell us about the building and the team of JCAP.
Thank you, Harry. And so this is just a quick remark on what it's like to work in this hub that was the vision of Secretary Chu. And I'm a big fan of the hub model. It's been fantastic to be in this building, been fantastic to be part of this team. This building was built to support the work of a team. And the team that works in this building spans everything from quantum chemistry to civil engineering, all working side by side, all sharing laboratory space, all sharing ideas. And that fast flow of ideas and the fast flow of results within this building and between our sister building down on the Caltech campus has been just thrilling to be part of. I see many of my colleagues out here and standing on the tarmac, and I thank you all for your hard work and look forward to continue working with you in this wonderful space. Thank you.
Well, our honoree today, Steve Chu, those of you who know him know that he's a very shy, retiring sort. Steve changes the world around him wherever he goes, and many people have recounted how they have experienced that. I certainly did when just a little bit before he became laboratory director, he called me one day and said, I'm really thinking about how it is that Berkeley Lab could really become a place that is a locus for thinking about how science can change the whole way we think about energy and environment. And I said, that's a great idea. And he said, well, would you help me? And I thought, oh, okay, that sounds really great. I had no idea how much he would upend my life. And he has in the most wonderful way. And I think he's done that to hundreds and thousands of people, certainly to everybody here at this laboratory. His leadership when he came here, he reset how we think about doing things, the scale and the style in which the work is done. And it's a style that really cuts quickly to the chase, really tries to find out where we're limited and where we're not. But then, although it focuses in on trying to solve a problem, it tries to do it at the most fundamental level, the deepest level, and therefore it finds the solutions that are really at the core for our future. And that vision while he was here was so compelling, it energized our whole community, and it also set him on a path where he could leverage that to a higher scale. And I think his deep devotion to science really altered the whole way in which science is viewed in our nation's leadership, and at the executive, but also at the congressional level. It set a new standard for thinking about how we should be approaching problems as a society and how science can engage more deeply with all spheres of public life. And so he's a truly transformative figure, and our association with him during the years when he was here was very special to us, and we're just so happy that this building can bear his name because he's been a great leader to us and someone we will always hold dear. Steve.
So I have to say I hadn't prepared any remarks, but I do have an hour-and-a-half PowerPoint. No, seriously. First, it crossed my mind. No. First, let me say how deeply honored I am to be here for this occasion. My deep thanks to everybody involved, starting with the Simons family, but also all the really great people at Lawrence Berkeley National Lab and on campus. I'm just the figurehead for everything that's been going on. I would like to say, I look at all these faces, lots of friends here, divided loyalties between Stanford and Berkeley, clearly. But I was a graduate student here, I was a postdoc, and they made me assistant professor, and so a lot of me feels very, very dear to both Berkeley and Lawrence Berkeley National Lab. because I was an LBNL employee for those 8 years I was here. They unfortunately didn't want to include that time in my retirement benefits, which is to this day a sore point because I was never vested by 5 months for University of California. I'm just throwing that into the ether. But in any case, the vision that many of these others spoke about is something that is where I thought the opportunity to lead Lawrence Berkeley Lab for even a brief period of time, where you have some of the truly best scientists in the world that can put together teams to solve problems, was in the end too tantalizing. And I think this laboratory has exceeded my wildest expectations of what could be done. Let me just briefly connect a few of the dots for those of you who are not embedded in what the people in this building, what JCAP is trying to do. What they're trying to do first is to use sunlight and make hydrogen, splitting water. We also need to capture carbon dioxide from fossil fuel plants, from a lot of things, and we really need an electric one of those. But to capture carbon dioxide and use very inexpensive electricity, which solar and wind will give us. Within a few decades, solar and wind will be far cheaper than any form of fossil fuel, even if natural gas stays at $4 a million BTU. To go uphill, to combine hydrogen and carbon dioxide, to make methanol, to make linear hydrocarbon chains. Why do we want to do that? Because once we can make really competitive, inexpensive liquid hydrocarbons, we can put it in tankers, ship it anywhere around the world for a couple bucks a barrel. We know how to do that. We know how to store it on shore in different countries, 6 months, 9 months. And so you have a transmission line, an oil tanker. You have energy security, and then you can go to the places where renewable energy is least expensive and become energy producers. One of the most critical parts of that is splitting water economically. And I've just been told a couple of minutes ago that a major breakthrough is in the works to how to do this efficiently. We have a price tag. It's about I'm hoping you're shooting for about $1, $1.50 a kilogram. The world opens up at that price. 15 bucks a ton of capture. I think that's also possible for carbon. So what are we doing? We're recycling carbon dioxide. It's the recycling that actually goes to really long-term sustainability. It's not the burying of carbon dioxide. It's the recycling of carbon dioxide and energy from the sun. And so this requires some really great science to be done. When I came here, I still say it, I still believe in my heart, there are going to be bunches of Nobel Prize quality science discoveries in figuring out this problem. But also in figuring out this problem, this is one of the most important problems that science and technology and innovation really have to solve. And so it's great to have been a part of it. I'm still a part of it. The shout out to Arun Majumdar is that he's a ringleader in trying to, both at Stanford but much broader, to actually try to figure out how to do these things, to split the water, to capture the carbon dioxide, and to make use of very inexpensive electricity to go uphill in energy to make those hydrocarbons. It's a very big deal. I love working in committees that Arun has puts together. There's a couple. And I guess I'm reporting to Arun. Maybe not, I don't know. But I first want to end by also acknowledging the leadership of this laboratory, especially Paul Alivisatos. He has been a fantastic director. I think far better than I, but really his leadership in taking the lab from when I left to go to Washington has been truly outstanding. I have very mixed feelings that he's stepping down, going back to the lab, because another 5 years would have been even better. But I know he also wants to go back to the lab full time as well, and I appreciate that. But very deep appreciation to Paul, to Horst, to many of the other people. I see a bunch of associate lab, Don, Paulo. Also, I've asked David McGraw and Jim Krupnick to come back, some very trusted colleagues and people I really depended on when I was director. Unfortunately, Gene Cummins is having some health problems, so he's getting some hospital checkups to see what's the matter, so he couldn't be here. But again, thank you all for being who you are, for doing what you're doing, and it's very simple. What are we doing? We're simply need to save the world, and it's going to be science that's going to be at the heart of that solution. So thank you.
See, that's not so hard. Okay, so we have a moment now. Come on, Steve, come on to look out here. We're going to unveil on the side of the building the sign of the building, and then we'll do the ribbon cutting. So why don't the folks who are going to be part of the ribbon cutting come on up, and first we'll watch the unveiling of the sign, then we'll go cut the ribbon. Okay.
Provost Steele. You. Mayor Bates.